You open a website, and in milliseconds it loads. But the server could be thousands of miles away. So what actually happens? In a world without a CDN, your request would have to travel the full distance, creating high latency as it traverses dozens of hops across the open internet. The journey starts with DNS. Your device queries a resolver. Instead of returning the origin server's direct address, the resolver looks for the CDN. The CDN returns an edge IP, steering you toward their global network. That IP is advertised from many locations around the world using Anycast. The internet's routing protocols automatically send your request to the nearest available node, ensuring the shortest possible physical distance for your data to travel. Once reached, your device establishes a secure connection with the edge node. With modern TLS and session resumption, data flows with minimal setup delay. The request reaches the CDN edge node. This is where the magic happens. Now, a critical decision is made based on the content you're asking for. The edge node checks its caching rules, looking at the instructions sent by the server. It determines if this specific file is already stored locally or needs to be fetched. If the content is already in the edge's memory, it's a cache hit. The data is served instantly without ever needing to contact the original server. If the content isn't there, it's a cache miss. The edge must now go upstream. But it's smart. It collapses multiple identical requests into just one upstream trip. This prevents the origin server from being flooded by a sudden spike in popularity. Instead of going all the way back, the request might stop at a regional cache, an origin shield. This tiered hierarchy further reduces the load on your primary infrastructure. Finally, the origin responds. But the journey doesn't end with just delivering the data. The CDN stores a copy locally, ready for the next person who asks for it. For dynamic content that can't be cached, CDNs optimize the path using persistent connections. The edge maintains pre-warmed connection pools, so requests are forwarded without a new handshake. This dramatically speeds up dynamic data like personalized feeds or shopping carts. The edge also acts as a security layer, filtering out malicious traffic and DDoS attacks. It runs code and security filters close to the source of the attack, protecting your core. The journey concludes as the response travels back, much faster than the original path. One request, resolved by DNS, routed using Anycast and served from the cache, providing a faster, safer, and more reliable experience for every user on the planet. If you want to understand what really happens behind the scenes, subscribe.